Hello. In this presentation, we will explore the track and trace capabilities of blockchain technology. These capabilities can be applied to many use cases. For example, the Drug Supply Chain Security Act, the European Union Deforestation Regulation of 2023, and semiconductor export controls. In this presentation, we will be focusing on the European Union Deforestation Regulation of June 2023. This law prohibits the sale of certain commodities, including palm oil in the EU, if they are linked to deforestation or forest degradation. Blockchain is an immutable, cryptographically secure, decentralized ledger. In addition, Ethereum, the blockchain technology used in this scenario, is programmable so that it can be adapted to specific use cases. Scalar is an application built on the Ethereum blockchain. It resembles a traditional ERP system with one key exception: there is only ever one copy of a transaction. The palm oil supply chain is exceptionally complex with many parties and processes involved. For example, cultivation, harvesting, transportation, milling, refining, shipping, distribution, and retail. In this scenario, we will focus on just three components of the palm oil supply chain: milling, refining, and distribution. Here we can see the three companies involved. United Milling, a miller of palm husks, and Global Refineries, a palm oil refinery both based in Brazil, and Allied Distribution, a European distributor. For simplicity, we will give them identical organization structures. There are two legs to this scenario. First, United Milling will ship crude palm oil to Global Refineries in bulk. Second, Global Refineries will ship refined palm oil to Allied Distribution in barrels. Now let's take a look at how business entities are represented in Scalar. As mentioned earlier, Scalar resembles a traditional ERP system. Users, which correspond to companies or legal entities. Partners correspond to profit or cost centers. These can be configured to any depth and complexity. Each of these entities is represented as a blockchain address. In this context, an address can be thought of as the user submitting a transaction. In order to place a purchase order on another user, a partner must first register that user as an external partner, just in the same way as a vendor would be approved. Scalar supports hierarchical approvals, but for simplicity we will grant purchasing authority at the plant level. When a transaction is posted, a shipping partner is designated by the client application based on lead times and availability. The addresses of the user, partner, and external partner are written to a shared transaction register, and pointers are placed at the addresses of all relevant addresses. It is this transaction register that is the key defining feature of Scalar. When a transaction is posted, Scalar emits two events: a track event at the transaction header level and a trace event at the line item level. Events are timestamped logs that are written to the blockchain. These can be easily queried subsequently. Every time there is a change to the status of a transaction, and track event is emitted. Here we can see the events for approval, shipment, receiving, and payment. A batch, or lot, is the result of a manufacturing process or transformation. It is primarily an identifier but may also contain additional information. There are input batches and output batches. As the input to United Milling is a raw material, there is no input batch. Now, let's introduce Allied Distribution, the third party to our scenario. Allied registers Global Refineries as a vendor and places an order for Grade 2 refined palm oil for delivery to the Amsterdam warehouse. A transaction is logged to the shared transaction register as seen in the previous step. Now, let's play the scenario through from the start. United Milling ships the crude palm oil to Global Refineries with batch information supplied. A production order is created by Global Refineries, where the output batches from United are consumed to create an output production batch. The output batch is shipped to allied distribution with the constituent input batches. In this way, n-generational many-to-many traceability is enabled. The transaction register continues to update in this manner. This scenario will now be demonstrated in Scalar. First, let's revisit the user structures of the parties involved. United Milling, Global Refineries, and Allied Distribution. Let's start by taking a look at the United to Global transactions. Here we can see the UI for the shared transaction register. 3 transactions have been posted and processed through payment. Taking the first transaction as an example, we can see the tracking information at the transaction header level. Tracking captures the stages of the transaction and emits timestamped events for approval, shipping, receiving, and payment. Traceability is at the line item level. It is keyed off a unique batch number. Shipping and receiving events are emitted at the line item batch level. Positioning to the São Paulo plant under Global Refineries, we can see the same transaction but this time from the purchasing perspective. Now, let's complete the scenario by posting a transaction at the Amsterdam warehouse under Allied Distribution. A transaction has been submitted for approval. As it is under the partner limit, it will be immediately routed to the counterpart shipping plant. Positioning to the São Paulo plant, we can see the transaction ready to ship. Batch information has been entered at the line item level. Here we can see the output batch created as a result of the refining process with the constituent input batches, that is, the batches previously shipped to the São Paulo plant by United Milling. Once the transaction has been submitted, we can take a look at the updates to the trace event logs. Here we can see that a shipping event has been emitted, along with the input batches. Positioning to the Amsterdam warehouse, we can see that the transaction is ready to receive. Once the transaction has been received, the track and trace logs are again updated. To restate, in Scalar, there is only one copy of a transaction, and so only one set of event logs. Returning to the Porto Velho plant under United Milling, we can see the where used log updated as the batch has been consumed by Global Refineries and shipped to Allied Distribution Amsterdam warehouse. The cash flow panel displays a summary of all transaction by stage and status. Counterparties see a mirror image of this panel. Finally, let's have the Amsterdam warehouse submit a payment authorization for the Global Refineries purchase order. Payment is authorized at the partner level, but funds are transferred at the user level in the same way that one company would pay another by bank transfer. This concludes the demonstration segment of this presentation. Scalar was developed as a standalone application but can be integrated with existing ERP systems such as SAP or Oracle. In this presentation, we have seen how blockchain technology can be applied to the problem of track and trace for transactions without the need for centralized governance or the overhead and cost of traditional technologies. Thank you for watching.